Okay, so just as in the last video, we are now going to discuss, of course this is going to be done very much analogously. We're going to discuss the reduction formula for various powers of sine theta, the integrals of various powers of sine theta d theta, okay? And you almost don't even need to watch this video if you watch the last one, because this is done analogously. So as I've said, in an instructive sense, my instructive comment to you, the viewer, is if you watch the last video, maybe don't watch this video or freeze this video here. Try to do it on your own, and then maybe fast forward and see your end result if it matches up with what I'm doing. And if so, then I think you would have gained some mastery over the procedure. Okay. Here too, we're using the integration by parts formula, so that's one that we've asked us to memorize, and we've done this many times. So the integral of u dv is equal to the product of uv minus the integral of v du. Okay, and again, I'm going to call this integral that we're interested in as I. And so, as I did in the past, let me just make that comment here too. So this is going to apply for n, a positive integer, greater than or equal to 2. Okay. So, alright, well, just as we did in the last video, we're going to write this as the integral of sine to the nth power theta. I'm going to rewrite as sine to the n minus 1 power theta times sine theta d theta. And here we will do the integration by parts by letting u be the first piece, so sine to the n minus 1 power theta, and then dv, we will let it be the balance of the terms there, sine of theta d theta. And that means that if I differentiate both sides on the u, I get the power n minus 1 coming out in front, sine, we knock it down by 1, so it becomes n minus 2 theta. Then by the chain rule, I have to do the sine, the derivative of the sine is cos. And again, by the chain rule, the derivative of the theta is d theta. And then if I integrate both sides of the dv, I find that v is equal to minus cos theta. Okay? And now, applying the integration by parts, I do, of course, the product u times v, which is this first piece right over here. And that's going to just give me minus sine to the n minus 1 theta times cos of theta minus the integral of, then I do v times du. It's going to be minus cos theta times all this stuff, so times n minus 1 sine to the n minus 2 power theta cos theta d theta. And then we get minus sine to the n minus 1 power theta cos theta minus times minus is a plus, integral cos times a cos is a cos squared. And I'm doing the same mistake I did in the last video, and then we get that n minus 1 term coming out first. That's a constant. So integral cos squared theta times sine to the n minus 2 power theta d theta. And like we did in the last video, we're going to invoke our most famous trig identity that we've done many times in past videos. And so here it is. I'm going to write cos squared instead as 1 minus sine squared theta times the sine raised to the n minus 2 power theta d theta. And then I'm going to distribute, so we get this is minus sine to the n minus 1 power theta cos theta plus n minus, so okay, if I'm distributing, that becomes n minus 1 integral of sine to the n minus 2 theta d theta minus the other part, n minus 1 integral of, now the sine squared theta times sine to the n minus 2 theta d theta just gives me the sine to the nth power theta d theta. And we recognize once again that this integral right here is what I was calling I. Okay, so I'm going to take this I to the other side of the equal sign, and that's going to result in the I that I had sitting over there to begin with, plus this I, which is the n minus 1 times the I, is equal to everything that is left on the right hand side, minus sine to the n minus 1 theta cos theta plus n minus 1 times the integral of sine to the n minus 2 power theta d theta. And now, once again, the left-hand side, I plus the quantity n minus 1 times I, all reduces to just n times I, is equal to minus sine to the n minus 1 theta cos theta plus the quantity n minus 1 times the integral sine to the n minus 2 theta d theta. And if you divide both sides by n, you find the result that we were interested in. That is to say that I, which is equal to the reduction formula integral of sine to the nth power theta d theta is equal to minus 1 over n sine to the n minus 1 power theta cos theta plus n minus 1 over n integral sine to the n minus 2 power theta d theta. And as I made the comment in the last video, let me make that here as well, just for completeness sake. Notice in this formula that whatever n you choose, that let's just say we chose n to be 6. So far I've developed integrals of various powers of sine up to the power 5. But let's say we were interested in doing the integral of sine to the 6th power. So n in that case becomes 6. Notice in this integral back here, notice that I would necessarily need to know what the integral of sine to the 6 minus 2 power is, that is to say the integral of sine to the 4th, which is no problem since we've already developed it. So the reduction formula always has this n minus 2 integral, or the power of the integral of the power to the n minus 2. So you will always have to know something 2 steps behind where you're interested. That's the point that I want to make. Or put another way, if you've developed a bunch of integrals of various powers, you can always find, using the reduction formula, another one 2 powers higher than the last one that you developed. So we developed up to 5. I can find, using this formula, the integral of sine to the 7th power. But if I wanted to do the integral of sine to the 8th, then I would necessarily have to have, first and foremost, the integral of sine to the 6th. Okay, that is all for today. We will see you in a future video.